We can also talk about a point furthest from the line theta is equal to pi over 2. Now considering this graph of r is equal to f of theta, the point furthest from the line theta is equal to pi over 2 would be this point here. This should be the highest value that x can take for this particular graph. Now since x can be expressed as a function of theta as x is equal to r cos theta, we can treat the point furthest from the line theta is equal to pi over 2 as a stationary point such that dx by d theta is equal to 0. Let us look at an example that involves this concept here. Here is a question from a past paper. If you'd want to attempt it, you may do so before checking out my solution. Okay, so let's look at it. The curve C1 has polar equation r is equal to theta cos theta for values of theta ranging between 0 and a half pi. On A, the point on C1 furthest from the line theta is equal to half pi is denoted by P. Show that at P, 2 theta tan theta minus 1 is equal to 0, and verify that this equation has a root between 0.6 and 0.7. Okay, so here we are talking about a point on the curve that is furthest from the line theta is equal to a half pi, which means we are talking about a stationary point where we are going to say dx by d theta is equal to 0. So let's start by finding x. We know that x is r cos theta, and in our case here, r is theta cos theta. So we'll be having here theta cos theta times cos theta, which means that x comes out as theta cos squared theta. So we are now saying dx by d theta is equal to, and we differentiate the product, so that will be cos squared theta times the derivative with respect to theta of theta, and it's plus theta times the derivative with respect to theta of cos squared theta. And this is all going to be equal to 0. Now differentiating theta with respect to theta, we get 1. So we'll only be having cos squared theta here. And it's plus theta of differentiating cos squared theta. We get minus 2 sine theta cos theta. And that's all equal to 0. Now we'll be having cos squared theta minus 2 theta sine theta cos theta, and it's equal to 0. Now from here I can factor out cos theta, and if I do that, I'll be having in the bracket cos theta minus 2 theta sine theta, all being equal to 0. Now it's either cos theta is the one that's equal to 0, or cos theta minus 2 theta sine theta is equal to 0. Now you need to understand that cos theta cannot be equal to 0, considering that we have r being equal to theta cos theta. Because if that is so, then that would mean that r would come out as 0, and we won't be talking about the point furthest from the line theta is equal to half pi in such a case. So here we're saying that cos theta cannot be equal to 0, so we do not have a solution from this. And from here we can divide by cos theta all the terms. If we do that, cos theta over cos theta should give us 1, and it's minus here sine theta over cos theta is tan theta, so we get 2 theta tan theta, and it's equal to 0 divided by cos theta gives us 0. So what we can do here is divide all the terms by minus 1, so that this comes out as 2 theta tan theta minus 1 equal to 0. And this is what they wanted us to get, 2 theta tan theta minus 1 equal to 0. So I'll say here, hence shown. Now the question also goes, verify that the equation has a root between 0.6 and 0.7. So what we do here, I'll say let f of theta be equal to 2 theta tan theta minus 1. Therefore, we can find f of 0.6 and f of 0.7. For f of 0.6, I'm substituting 0.6 for theta. So that'll be 2 of 0.6 tan of 0.6 minus 1. So it's 2 times 0.6 tan 0.6, and that's minus 1. And we get minus 0.179. So that's minus 0.179. And for f of 0.7, that's 2 of 0.7 tan of 0.7, and it's minus 1. And if we type that into our calculator, that's 2 times 0.7 tan 0.7 minus 1, and we get 0.179. 0.179. So there's a sign change here from negative to positive. So we're going to say there's a sign change, and therefore a root does lie between 0.6 and 0.7. So that's how we verify. Let's go on to part B. On part B, the question goes, the curve C2 has polar equation r is equal to theta sine theta for values of theta between 0 and a half pi. The curves C1 and C2 intersect at the pole denoted by O and at another point Q. So here on B they say find the polar coordinates of Q, giving you answers in exact form. So here we are talking about the points of intersection of two curves. Now the equation of C1 is r is equal to theta cos theta. So let's have theta cos theta being equal to the curve theta sine theta at their point of intersection. Now we can simply divide both sides by theta cos theta, and this side as well by theta cos theta, and so we cancel out here and we get 1, and we know that sine theta over cos theta gives us tan theta, as the thetas also cancel here. So this is going to give us tan of theta is equal to 1, and therefore to get the value of theta, that will be arctan of 1, which comes out as pi over 4. So we now have the theta value at their points of intersection, and now we need to find the value of r. So we are now saying, since r is equal to theta cos theta, if theta is pi over 4, then r will be equal to pi over 4 cos pi over 4. And what does this give us? We'll be having pi over 4 of cos pi over 4 is actually root 2 over 2. So we get the value of r as root 2 over 8 of pi. So therefore the coordinates of the point of intersection, we write them as polar coordinates, will come out as r, which is root 2 over 8 pi, and theta, which we got to be pi over 4. So these are the coordinates. Let's go on to the next part of the question. That's part C. On part C, the question goes, sketch C1 and C2 on the same diagram. Now let us make the sketch on this plane. So on this plane, we are going to have values of theta ranging between 0 and a half pi. And I'm going to have 4 intervals within that range, such that we have pi over 8 here, pi over 4, 3 pi over 8, and pi over 2 right here. Now, using the equation r is equal to theta cos theta, and substituting theta into this equation to get the values of r, I get the table of values coming out like this. And for the graph, r is equal to theta sine theta. If I substitute the values of theta into this equation, then I get the table of values coming out like this. So we now have the two table of values, and we can now make a plot. Now the r values will start from 0 all the way up to 2. So let's start with the graph r is equal to theta cos theta. When theta is equal to 0, r is 0, so the point is this one. When theta is pi over 8, then r is 0.4, so the point should be this one. For pi over 4, we have r being 0.6, so we can put the point right here. 3 pi over 8 for theta is a corresponding r value of 0.5, so the point should be here. And lastly, when theta is pi over 2, r is 0, which means we come back to 0. So if we join these points, then the graph will come out like this. Now for r is equal to theta sine theta, when theta is 0, r will be 0. And so the point is at the pole. And when theta is pi over 8, r is 0.2, so 0.2 should be somewhere around here. When theta is pi over 4, r is 0.6, so 0.6 should be here. When theta is 3 pi over 8, r is 1.1, so the value should be somewhere around here. And lastly, when theta is pi over 2, r is 1.6, so the point should be up here. So if we join the points, then it should come out like this. So we now have the two graphs sketched. So let's put this on paper. So we have here the initial line, theta is equal to 0. And we also have the vertical line, pi over 2. So for C1, the curve is like this. And for C2, it was going like this. So this is C1 and this is C2. Let's go on to part D. Find, in terms of pi, the area of the region bounded by the arc or Q of C1 and the arc or Q of C2. So this is basically the region bounded by the two curves. Now if we look at our diagram, they're talking about the region bounded by the arc or Q. So this is O, and the point Q is the point of intersection of the two curves. So Q should be this point here, according to the information we had gotten in part B, where they were saying that the curves C1 and C2 intersect at the pole denoted by O and at another point Q. So this point here is Q. And we also learned that at Q, which is the point of intersection, the value of theta is pi over 4. So it means that we have a half line theta is equal to pi over 4 passing through that point. So we have pi over 4 here. So the region for which we want to find area is this region here. Now to find the area, we will need to first find the area of the region bounded by C1 from theta is equal to 0 to theta is equal to pi over 4, and subtract the area bounded by C2 from theta is equal to 0 again to theta is equal to pi over 4. So we are saying the area is equal to the integral from 0 to pi over 4 of half of r squared. So we are going to say area under C1 is theta cos theta, and that's going to be squared. So I'll have it, and it's minus area under C2, which is theta sine theta squared, and it's with respect to theta. So I've just combined the two. So let's work on this. So here we have half figured out, and the integral from 0 to pi over 4 of, we'll be having theta squared of cos squared theta minus sine squared theta, and is with respect to theta. So from here, I'll be having a half of the integral from 0 to pi over 4 of theta squared, and for cos squared theta minus sine squared theta, we can use the double angle formula such that this gives us cos of 2 theta, and that's with respect to theta. So for what we have here, we are going to perform integration by parts. So from here, I'll say let u be equal to theta squared, and dv by d theta be cos 2 theta. So here we'll be having du by d theta coming out as 2 theta, and here v will come out as integrating cos 2 theta. We get half of sine 2 theta. So it means that we'll be having, in this case now, a half, which is this half that's already here, of uv, which is theta squared times half of sine 2 theta. So that will be half of theta squared sine 2 theta, and we have the limits here from 0 to pi over 4, and it's going to be minus half, which is this half here, times the integral of v by du by d theta. So multiplying this 2, we get 2 theta times a half sine 2 theta. So that will give us integral from 0 to pi over 4 of theta sine 2 theta, and that's with respect to theta. So we can continue simplifying. So here I'll take up more space. This part is actually a quarter of theta squared sine 2 theta, and we have our limits here. That's from 0 to pi over 4. And for theta sine 2 theta, we're going to do integration by parts again. So it's going to be minus a half, and let's do integration by parts for theta sine 2 theta. So I'll say again, let u be equal to theta, and dv by d theta be equal to sine of 2 theta. So du by d theta should give us 1, and v here integrating sine 2 theta, we get minus a half of cos 2 theta. Okay, so let's put that in a bracket. That will be uv, which is minus half cos 2 theta. And this should be with the limits from 0 to pi over 4. And we'll have minus of minus a half again. So it's plus a half of the integral from 0 to pi over 4 of v by du by d theta, which is minus a half cos 2 theta, and that's with respect to theta. So we can simplify this. So taking it up to here, we'll be having, combining the whole thing, a quarter of theta squared of sine 2 theta, and minus a half and minus a half is a quarter, so it's plus a quarter of theta cos 2 theta, And here, half and minus a half gives us a quarter. And if we integrate cos 2 theta, we get a half coming out. So we'll be having here minus an eighth of sine 2 theta. And that's for the limits from 0 to pi over 4. So now we can simplify. Substituting pi over 4 into this whole thing, we'll be having a quarter of pi over 4 squared. And it's sine of 2 of pi over 4, which is 2 of pi over 4 here. And it's plus a quarter of theta, which is pi over 4. And it's cos 2 of pi over 4. And it's going to be minus an eighth of sine of 2 of pi over 4. And it's minus, now substituting 0 into this whole thing, we are going to get 0 all throughout. Now for this part, sine of 2 of pi over 4 is like sine of pi over 2, which gives us 1. So here we'll just be having a quarter of pi over 4 squared times 1. So we just get pi squared over 64 from this. And here on this part, cos of 2 of pi over 4 is like cos of pi over 2, which gives us 0. So it's plus 0. And it's minus, here we've got an eighth of sine of 2 of pi over 4. Remember we said sine of 2 of pi over 4 is sine of pi over 2, which is 1. So we get an eighth here. And it's minus 0, which is here. So we can simplify this to pi squared over 64 minus 1 over 8. So this is the answer that we get.